Hello everybody. In this video, we're going to continue working on our project application. And the main idea here is to start Serama or authorization endpoint. That way we can start protecting our project and tasks. Well, actually, we will be protecting the API endpoint completely. So that will be really interesting and really important in order to have a specifically a full authentication method across the board. We'll not be using authorization yet. Um, well, probably let's discuss that at the end of the video. But my focus here is I want to create users and I want to save those users on the database. And then we will actually calling, verifying that the user exists in order to log in, and we'll provide the access token and refresh token in the backend per se. After this, we will deploy, and then we can start working in our view app that consume our backend API. I think that you take this project as an example at the end for your final project, the way that you're doing. So you can see one way to do things. Of course, it's not to be exactly the same. Every development and every opportunity is different there, and they're different. For now, what I want to use to focus mostly is in the example per se, in how to protect the API endpoints and how to establish those particular elements. So let's get started. The first thing, before I'm actually even running my project, I want to install bcrypt.js. So do npm install bcrypt.js. And so what is that? Well, bcrypt is a pure JavaScript implementation of the bcrypt password hashing algorithm. And it's pretty cool because it's 100% JavaScript and it does actually make it work in Cloudflare workers. So what's bcrypt? What it does and what it matters? So there are regular different functions that you can hash different values. And let's say, for example, SHA 256, like SHA 256, are designed to be really fast way to hash a particular password. The problem about those is really cool about checksums. What is a checksum? Just to verify when you download something from the internet, you provide the checksum and say this is the checksum of the file. So when you verify it, and you will say, well, it's actually the same file with the same information and the same size, things like that, right? But it's really dangerous for password because it's actually a fast algorithm. It means that an attacker can try billions password through to try to guess that if the database actually leak. So the way that it works, hashing what it does is to deconstruct a string to another in a way that it cannot be constructed back for. We do that. We hash our passwords in the database. We're going to be saving usernames and passwords we will use in local authentication. But it's really important, never save password in plain text. If you save password in plain text, you screw. Because if something happened with your database or those leaks that we've seen sometimes happen on the internet, that this company database was been leaked, this other company has been leaked. If you save your user data unencrypted or uncached, that's a big problem because you pretty much expose all those passwords. So it's important to hash them so you never have the real password. The cool thing about the hash is that it has a salt, a value that is randomly generated, and that salt will determine how the hashing will become. And then you will save the hashing. The cool thing about this is when you verify, you need to hash the plain text, and then you get the plain text from the user, and you get the hashed version that you had in the database, and you rehash it again just to see if the hash is actually the same. And that's a pretty cool thing about this particular element. So that's one of the best way to do it is through actually the bcrypt algorithm. It's one of the newer ones, well, newer in a way. But it uses a concept of called salting. salting is a cost factor that will determine how that randomness of the hashing should be. So Bcrypt is intentionally slow. So we will be using in this project hashing of value of 10, right? That will make it roughly that every hashing is around 100 milliseconds instead of more immediate. That means that turns if your database get exposed, instead of having billions of password check at the same time, you just turn those a couple of thousands. And in order to find that through brute force, it would pretty much become impractical. So the bigger the salt, the better. The problem with the bigger salt is actually slower to generate a password. So a salt is actually pretty cool to determine. And before, well, let me just install it for now. Okay, we have that there, and let's back to our code. So one of the cool thing, and let me just use something like here. We will be using, for example, a hash password, right? And let's say that password will be cool password, right? So when we hash it and we send a cool password, this will pretty much change it or determine it. And this is not real JavaScript, nothing, it's just to show it. Um, something like, I don't know, let's say, for example, something like 2B, then X, I don't know, KJ9, B, whatever, A, B, C, D, right? So if we had will something like that really long string with a prefix, that actually the prefix will be the hashing or the salt element that will allow us if we have a somebody else with the same password by any chance, if somebody this will be, let's say, user one, or let's say by any chance the user two choose the same password for any reason. The cool thing is the hashing it will not be the same. The hashing will be something different. Let's say, I don't know, something like, let's say something like this, no, whatever, and it will be something, I don't know. So even when you have the same password twice, you will never do that. The hashing it will be different because the way the bcrypt works, it add the salting element as a prefix. I don't have like, and that prefix will be the quantity of numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or something like this, for example. So you will never know if your database get exposed. The hacker will not know exactly how much to use. So you need to compute every comparison with every other comparison to try to find the password per se. And that way it just doesn't work. So that's the cool part about it. So, and that's the cool part about Bcrypt. So let me get out of this file, let us save it, and let's move forward with the element. So if we don't have something like Bcrypt, that means that hashing or that salting, we need to be stored somewhere. The cool thing the Bcrypt does that is in the prefix of the name. So now that we have that, we can start using it. But I just wanted to have that correctly in our file. Let's go to our schema, because the first thing that we need to do now is to establish our new table. Let me reduce the projects as the task one. We don't need to focus on those for now. And I want to be importing unique index. There you go. Because we'll be using that one. So the basic thing that we can use here is define in our database a users table. And in this table, we define the name, the users, and then we can actually define the configuration that we'll be using. So something that we need to have an ID, right? There will be an integer on the column we'll call ID. It will be our primary key. And let's make this the array increment to true, right? The other things that we need, let's say, the username or the email. Let's actually say that we are choosing 7 emails. And that will be a text. It will be email. It should not be null. And I want this to actually be unique, right? We need to keep consistent. We don't have, if we are using email as the username, we don't want to that actually be a duplicate. Let's do password hash, and I'm specifically saving as a hash. That would be also text. So column will be password hash, and it will be also not null. And then we can just use created at and updated at here. Now we are not going to be updating any user, but just to keep the consistency. What else you can put here? You can have a profile table, or you can hold the profile element inside the user. That's whatever you want to have it. And we can say things like hobby, bio, name, last name, things like that, right? So you can imagine grow. For simplicity, I will be skipping those here. But just to think about that's where the user, and we will be handling those. So now that we have this information, we have a unique in the email. Let's actually make or index, unique index percent. So let's get this, and let's say as simple as we're getting the table, and from the table, we're going to do unique index. That will be, it will call IDX, users email on the same table. Oops. And let's do on the email field, right? So here, this will work to create a user table. We will be storing everything. Now we can do a repository that will allow us to handle this information. But before we proceed that, because we just changed it, we can do a migration. So we can do simple npm run db generate, sorry. That will create um, another file. Cool. We can see the users table. You just click here with 5 columns and 2 indexes. If we go back to migration, we have a new SQL file, and this the SQL element to create the users with the unique index for the user email and with the actual IDs, right? So that's what we have here. Actually, what is doing both? It's actually weird. Well, I don't know why I did it twice. So but this is the one that we defined it, that we needed. Well, let's keep it as it is for now. It is important just to define it the way that the schema needed. So that's what we're saying through here about that particular schema. Now with that, we can just run now on migration. We can do npm run db migration local. It will connect. It will execute what is missing, say yes, and just run. Remember that we can go back to a Wrangler folder, state D1, and we have the database through here. And now we have the users table right here. So we can actually see it works. It's doing what it's supposed to, and it has what it's supposed to. So that's the pretty neat part through here. The other thing that we need to be doing now that we have we can proceed. Let's proceed or not. Let me talk about another element. If we want to simplify the element, we can just keep as it is, but we want to do a little more production-ish ready application where we are not going to be using only user, we're going to be using sessions. And those sessions will help us to define different, save the hashing part of our tokens or refresh token itself. And we can define those if those are actually valid. In a way, we keep the state in the database side for the refresh token, and we can actually hit the refresh endpoint to call that. And I will show you that in a minute. We'll do actually log. So what I want to see is get back to my schema, and I will just copy and pasting another table that will have it through here. And let me change this like this. Perfect. So in this table, let's change this to be user ID. I like to have Pascal case and snake case on the names. User ID. Perfect. Token hash. Remember, be careful with your typos. Actually, I need to be careful with the typos. So authorization, what we're going to be, we have our integer ID as the primary key, but then we have reference to the users through the user ID, and we'll save the token and when that token expires and when that token was created. So far, it will be pretty much the same day, but just to keep a consistency through there. We don't need to update a token, and it's just to save the session percent. So that will be the one that will insert whenever we do a login. We'll verify that this actually exists, and we insert the session through here. When do a logout, we need to delete from here. And when do a refresh, we'll verify if the refresh token exists here, and then provide a new access token. That will be the idea. So doing that will allow us to generate one more time. Now we have the sessions column table, and we migrate. So yes, and that. That will, if we come here, back here, we just click refresh if it's not there. And now we can see the session is right here. There's other things that you can save in sessions. Yes, you can use this for auditing purposes. You need to audit your application. You can have something like from where it's actually connected. You can save like the IP address, the client. So you would say it's a phone, it's a browser, it's a Windows, a Mac, it's an iPhone, Android, that kind of stuff, like user agents. You can save that information just to think about what else you can put in there. So we will be playing around between our users table and our sessions table, and we'll be filtering out through those elements. So now that we have that, let me just refresh, add everything. Cool. And let me put it, added bcrypt. Yes. And users with sessions schema. Right? Cool. So let's move forward now. Now that we have those two through there, let's and without those actually getting to the migrations, and then we are able to push those migrations, we can go to utilities and let's create some utility. Let's call it crypto. And we'll be using a couple of things in our crypto element. So let's say import bcrypt, and that's actually bcrypt.js from bcrypt. Cool. And let's do a const. Let's do, we have those in constant. Export const bcrypt rounds. Let's make this a 10, right? Bcrypt round. But that will allow us to import right? Yeah, it's complaining because it's not being used yet. So we need to have a couple of functions. We need to have export asynchronous function. Everything that is encrypted and unencrypted, we need to do asynchronous. Let's do function. Just call this hash password. So we send the password as a plain text. And the only things that we need to do, return bcrypt.js dot hash, and we hash our plain password, and we do that the X amounts of rounds that we define it. That's it. So we send a value, whatever password is going to be, it will hash it. We need to have another function. And let me actually copy this over. It will to verify the password. So whenever we need to log in, this will for register, right? We hash it and we save it to the database. When we do register, we need to go to the database, verify that user exists. If that user exists, we get the hash of the password and we check it with our plain one to see if they actually match. And we can have a function already called compare. That will be a Boolean. We'll say is true or false if that actually provide if the same password or not. Now, for the refresh token, let's do a unique identifier. And we can do something like this. We can have multiple devices, but that should be enough. And we need to, in a way, hash that. And we don't need to bcrypt anymore because these are really random. We can do a simple SHA-256 this time to hash it through that. And is with the text encoder function, we just encode or hash token. And then we do the buffer. We need to wait, and that's the part that will get the crypto pseudo digits with 256, the encoded. And then we just from universal in integer to an array from the buffer, like you're getting from the buffer, and we save and we return that one back. We passed her from 2, 0, and we just join it. That's what we're doing here. Like, don't think that much. It's just the way that SHA-256 needs to be done. And we save this as a one big string. It's going to be an array, the bytes, because it's just the different elements. We change those to hexadecimal. And we make a specific size. If that hexadecimal is less than 2 digits, we add 0 at the beginning. and then we join the array without without spaces. So we did a really big uh, text, pretty much. And that was just to hash the password. And that's the one that we'll need using in our crypto decision. So why here again? And the hashing through SHA-256 instead of Bcrypt, because this we need to be a little more faster. The randomness of the unique identifier already make this difficult, even there is a long-lived one. So we should be inside of what we need to be encountered through here. So that's pretty much the idea. The other utility that I want to add, well, let's actually just add those added crypto utils. I want to do the authentication utility. And for that, we're going to be the JWT component that Hono already has. So Hono provides, through Hono /JWT, we can sign and verify a specific JSON Web Token. And for those, we need to provide a couple of constants. So let's create those constants through here. And I will have this one. The access token will last 50 minutes, right? And the refresh token will last 7 days. And we define the days for the refresh token, and we just define here the seconds here. Now, why 50 minutes? Because this should be in seconds. So every minute have 60 seconds. So you do the math here, and another that the actual second value will be 7 there. So the first thing, we need to have a function here. We actually need to import from the uh, constants. Is actually not getting it. Not sure why not. Uh, oh yeah, I'm not exporting those. Export, export, cool. So we can have now through here. Yes, our autocomplete is working. And we do the refresh token, right? So the first function that we need to do is sign access token. We'll be sending the payload and we'll be building the payload. And we will define the secret. We'll be sending the secret. If a constant for now is math floor for date now over 1,000. And we return the sign JWT. With the payload, we add the EAT and when expires, and that will be whatever is now plus the seconds calculated. And this will be signed through a particular secret. We'll say that in a minute. To verify the token, we just need to execute verify. So let's export the function, we'll send the token and the secret, and we just verify that with HS256 to verify the token percent. And we need to calculate whenever the refresh token expire. So let's put it here as a function. That date will be a new date. And now we can get the date and we add the X amounts of days that we have here. So in a constant, we say that refresh token is going to be 7 days. So from today plus 7. And we return that date to isOstring. So those are just helper function, utility function that is actually working through us, right? For those, we can have to save it. And let's now go back in our data folder. Let's actually added authorization, authentication actually, utils. And now we need to start making um, database connections to see if our user exists or not. So for that, we need to create a couple of repositories. So we need to do the users. And let's keep the same name, that repository.javascript. Um, from here, let's just take the top. We need pretty much this, but we're not going to be just ascending. We just do ascending equal. And we'll be importing, instead of importing tasks, we'll be importing users. Right? The two functions that I'm thinking that we need to here will be find user by email, just to verify if the user exists, right? So we just need to have a synchronous function. And let's call this find user by email. We need to send our database, and we need to send the email itself, right? That will allow us to do const. We will query one value. That's why we just put it extracting that one. The user will be equal to await database, and we do select everything from users, right? But we say, well, where? Oops, what I'm doing here. Dot where, and here we define the equality function, and we say that users dot email will be the same as our email provided here. And let's use to lower case just to have a better assignment here. That will just allow us to query the database, and that will query whatever user there. We know that will return only one because email is a unique identifier. And we just need to return our user or null if that user doesn't exist, right? The second function that we need. So let's do, we need to find it and we need to create. Now, we are not going to delete a user. We're actually not going to do users endpoints either. I think those a little more outside the scope of this projects. But this would be the idea, right? That you need to handle the database, the user be able to delete their account. You need to add a deletion function and things like that, right? And delete and we handle then the user endpoints for every CRUD element if we want to. So for that is whenever we need to add like user administrators, the administrator can add X amount of users at the same time. Things like that, right? So you're thinking like I hope that this is just the fundamental part for you to think what else you can do about it, right? And how to move forward with the rest of the element. For now, we just keep in find user and create user. Export synchronous function to create user. I'm going to send the database. And we need to send two things, the email and the password hash. Right? So let's do const timestamp equal no ISO, and then do accounts created, await database, and we do insert inside users the current values. The email that will pretty much or email to lowercase. I'm doing like that because somebody put their email, I don't know, like John Smith at Yahoo. Yahoo, and I think nobody has Yahoo anymore. It will be exactly the same as John Smith at yahoo.com. So it doesn't matter how you type it, it will always save it in lowercase. That's pretty much what we're doing here. Right. We need to send the email. We need to send the password hash, will be the same as the password hash. And then created at will be the timestamp. And the updated at will be the timestamp too. We need to do returning. And after we do that, we just need to return created, right? Why didn't like it? Unexpected token. Oh, this is a comma. There you go. So we just insert to the database. We need to wait for that because it's asynchronous. And email password created and updated. Is we need to remove email from this one. It should not be there. So if we go back to our schema, that's what we see. Email password created and updated. ID will be automatically generated. So that will be our user repositories. Cool. So always email will be and create user receive password hash, not the route password. That's really, really important. Here we always sending the password hash, never the route password. Now, but this function doesn't need to do that. So whenever you call the repository, you already send the hash. And that's the one that we need to be careful. Let's create another file. Let's call this sessions. And for that, let me just copy over what I already have. Let's explain. What we need to hit, we need to create a session. That will be really simple, really similar. I go to the database, we insert the sessions, in sessions table, the user ID, token hash, when expires, and when it's created, right? That's it. We need to find a session by token hash. Remember, the tokens are already hashed. Actually, this should be like this, because user ID, we're keeping the same name. Token hash, expires at, this should be dated at, with lowercase u. Cool. And need to be returning. Find a session by token hash. We just need to select it and return the session or no. So it's really similar to the one that we have for users. But we can have a delete. This is how pretty much the logout works, right? So from session, you delete the from session, you delete whatever the session hash. Token hash is the token hash that you're actually sending here. and you will return the session ID to the element. That is what you're the only thing that you're doing. And just return true or false if the length of this one is over 0. If it's over 0, you return true. If it's less than that, will return false because you're selecting that session ID. That's why we're making a value and we need to make this to have a length per se. Now, the last one, the let expire session. We are not going to be using that one, but just as an example how to use it well. How can we do cleanup our sessions table? Well, we just delete from sessions wherever session user ID is the specific user ID and less greater than expires at a now. And that's it. That's what we can actually be using in the delete session, and there should be like a cleanup element. So let's add those and sessions repository. Cool. Now that we have a schema, we migrated locally. Now we have our utils, we have our repositories. We can now start doing our endpoints. Actually, before the endpoints, we need to do validations. So let's go back to validation. And let's go through here, validate with schema. Okay. Before that one, we need to have a couple of schema. We need to register schema. Register schema will be the schema used whenever a user register. So we need to have an email, property string and email. Say that this already duplicated. Let's see what is there. Oh, I think I need to import that. No, I should not. Use the email instead. Oh, there you go. A string is not needed anymore. Just saying that it's an email and be a valid email address. And we are telling also our password should be a string, password required, and we're making a size like of 8 character. So that will be a register schema. Our login schema will be similar. And we can actually delete this. We need to provide the email and the password. And the only error here, we just say the validation. We just validate that the password is actually present. That's the only thing that we're adding here. That's why I have a minimum of one. But in reality, we're just asking a minimum 8 whenever we register. So that will be it, catch it right there. Then we have the refresh schema and the logout schema. So for refresh schema, we need to send the refresh token, and for the logout too. Those actually are pretty much the same. And look exactly the same. We just keep it as is just to have the name and validated somehow, right? So we have the refresh schema. We need to send the refresh token, and to logout schema, we need to send the logout token. And for those, we just need to validate those 4 functions and send it to validate with schema, the same way that we use in the other ones, and we send it through here. So validate register, we need to send it, validate login, validate refresh, validate logout. And those are the ones needed. So what else we can do? Mm, I'm just thinking right now. I think that's it. I think we can move forward now with our actual router. Let's add this, added users and validation. Now we are not sending validation for the scheme for the sessions because the user will not provide the sessions. We will have handled the session in the backend 100%. The only thing that will be interacting will be with the user. That's why we do those particular user schema itself. Now that we have those, we can create our authorization route. For that, let's do import Hono. Let's do this one over here. Get DB. Cool. And we can do something like authorization is a new Hono. Actually, let me just import everything now that I have it. We need to import a lot of stuff here. From the, I didn't want to import because I was thinking it would look very red. But we will pretty much use everything here. From the session repository, we create session, delete session by token hash, and find session by token hash. Right? From our user repository, create and user and find user by email. For authorization, we need to sign the access token and refresh token expires at. So that's from the authentication here. What else do we need? From the body, we need to parse JSON body. We already know that. From crypto, generate refresh token, hash password, hash token, and verify password. Right. We need to import our API's errors, or send response, and the 4 different validations for the login. And that will allow us to have something really cool. The first that we'll be creating will be actually, or, and I didn't copy everything. There you go. Cool. Now I have rest left. So we do our post for register endpoint. So we need to parse the body, see that everything is there. We need to validate it with the register. And we know that whenever that validation fails, details have something and we send a validation error. And we think which one are, right? If not, if everything is valid, we connect to a database and we need to find that user, right? Our payload email has that. Remember that the register is email and is password. If that user already exists, we have a conflict and we send a 409 and you see what that email already exists. But if it doesn't exist, we need to hash the password. That's really important. Remember, we always hash the password. And we use the hash password from crypto and we send the payload password itself. Now that we have the user email and we have the hash password, we can create the user, of course, awaiting. All those are database connections, sending the email, payload email, and the password hash. Remember, don't send the payload password. You send the password hash. And then, because it's a created, we need to define our header. I know that the user's endpoint doesn't exist. We are not going to be created, but this is just to follow the best practices that we already have. So we say that's where this user will be living, right? We have like that endpoint in the future. And then we send the resource to our context. And we said which user. Here we actually not send the full username because we should not be sending the user password. So this is a way to have that, right? Just the fields that we need with the 201. We are specific removing the password to be setting. And that will be just our register endpoint. Login will be a little bit more complicated, but it will make a lot of sense with all the validations that we have. So let me paste those here. And this actually get DB. We need to, we do the same in every endpoint. We parse the JSON body, that is a valid JSON file, and we validate with the correct validation. This is a login post. That means we validate with the login. The same thing. If something's wrong, validation error. If not, we need to find the user. So we get our database, we find the user. And then here we just find credentials error. It's a new API error, 401, you not authorize invalid email or password. And we did it like that because we throw a credential error if the user doesn't exist. And why we do this? Because we need to hide user enumeration. Because somebody can be try to guess somebody else login. And if we send like password error, we say, oh, I have a correct username. This way we're obfuscating that. It doesn't matter if it's a username error or it's a password error, we will always be sending the credentials error in the login. That's it. We are just obfuscating, giving more information to the possible attacker. We need to think how they actually be able to do that. It's called enumeration. If we do a simple validation, what will happen is pretty much we will say, well, that user doesn't exist. So the hacker will say, I need to change the username. Then if the password doesn't match later, if that password doesn't match, we say, oh, I have the correct user. That's why we just obfuscated that part. And that's the cool element here. Before actually sending the password doesn't match, we need to verify password that was imported. And we send the password, plain text from the payload, and the user password hash that we query before. If that is correct, well, we need to sign or access token, create the access token per se. And we send that to user ID and the email. But then we send a secret that we don't have yet. We will have in a minute. That secret we need to be outside our code and will be handling like an environmental variable for our project. Now we have the access token. We need to create a refresh token and we need to hash it. Right? So we do the refresh token, we hash the refresh token, and we add the expire at, we just calculate when that token actually expires. And before we proceed, where we have the access token, refresh token, before we actually give those back, we just create a session. That means we go to a database and we push that session in. And we send the user ID, the token hash, and when it expires. And then we return back our access token, refresh token, and what token type it is, pretty much a bearer token. It's just information. Right? That's what we have here. So we have most of the elements now. I hope that it makes sense. Jump in this validation, try to find the user. If user exists, try to verify the password of the user. If password match, create the access token, create the refresh token and hashing it, get when that token expires to create the session. And after just the session got created, we return the resource with that particular data, right? Now, we need to have a refresh endpoint too. Whenever our access token expires, it's not valid anymore. We call that refresh point one time in the front end. And that will be through here. Okay. So it will be the same. Get refreshed, validated. If everything goes well, we connect to the database. We verify that token hash. We hash the token. We get the session. And this actually should be refresh token. File session by token hash. We send the DB and we send the token hash. If there's no session, you just unilateralize. Simple as that. If that session expires or we expire, we just send unauthorized, invalid expire refresh token. As you can see here, we are sending not giving more information because we're talking about security. It's a different part. Now, access token, we need to sign in again. We send the current session user ID, and we just send the JWT secret. Now, what I'm looking right now is I'm actually not sending the user email. That should be sending. Well, we can keep it as it is if we don't need it anymore. Or we just have something like this. As simple as that. A random internal ID that it doesn't have much value to the person. And just return that one and the token type. And that's it. Right? Let me just verify a couple of things. I need to have this not to make sense. Just verify that I have the same previously in the login. User password hash. Okay. Password hash, we're fine. Here. Create it, just to keep consistency across the board. Cool. The last thing that we need to do now is to handle the logout. And that's, I think, is simple enough to understand what we need to do. We post to the logout endpoint, validate the logout, the refresh token is there. There one should be token. I'm thinking that I'm missing a typo somewhere. We will see that in a minute. And the only thing that we need to do is just delete the session by token hash. And we'll just return 204 with a body of null. Simple as that. And we just export our authentication endpoints. Cool. Now that we have that, we need to do something about our secret here, right? Because we're using a secret that have not been declared anywhere. So one of the cool things that we can define in our Wrangler JSON, there is a part, and I think it's through here. If not, we just need to add it. Ooh, Let me see. Oh, I think my internet just fell a little bit. Okay. Cool. So what we need to verify in this particular element is the variable or the secret percent. And we need to add it in a way that is going to be executed in our application. So the things to do that is we need to handle a file. We can do a .env, but Wrangler uses something called .deb.barth. As you see, when you can add it, it gets graded out because it's already in our git ignore the part. So here we define our local development variable that will be the JWT secret. And let's just put this one over here. Super secret dev will only change it in production. And we need to find a new one in production and we need to push that one whenever we need it. That will load our JWT secret in our development environment. So if I actually save this and let me do a simple npm run dev, you can see that JWT secret now is being as a binding as an environmental variable. That means that we can actually just use it. We can exit anywhere in our code. So let's keep it actually running. Let's be as it is. And let's go back to our project to continue working. Now that secret needs to be saved somewhere inside Clover, and I will show you how to do that. But for now, let's keep it as it is. Okay. We have a route already, we have utils. Now we need to make a protection about project and task to be able to use a protected endpoint. In order to that means that we need to catch the call and do something about it. That's called middleware. A middleware is exactly the name mentioned, something that is between the request and the endpoint percent. And we're telling do something about it. So let's create in our source directory middleware folder and let's create authenticate.json. And that will be the name of our middleware percent. We need to import a couple of things. We need to verify the access token and send the error. And the only thing that we need to export is one function that has their context and next. And I will show you what next it is. So middleware, the way that it works, it will grab the context and it will push that context to the next element because you can have several middlewares in series, or you can actually have block it and respond right there. So the first thing, because I have my context already here, I need to verify if my authentication header is in my request. So I can do my c.request.header. I need to check if authorization, because that's the one that we'll be using. Authorization. I don't know how to English today. Sorry for that. There you go. So I have that. So the first thing that I need to verify if that one doesn't exist, or my authorization header doesn't start, be rare. Well, we just need to send an error. And what will be my error? We need to send the context. We need to send the status, will be 401. We need to send the message. Message will be unauthorized. And we need to send the code, the status, the code, and now the message. Let's actually put, I don't know, missing or invalid authorization header. So what we're saying here is, if I don't have the authorization header, whenever I send through here, block it right away as a 401. That's it. If it has it, well, now I need to verify that. So let me get the actual token. So const token. I know that my authorization header has bearer space and the access token. Bearer is 6 letters and the space is the same one. So I know that I just need to get my authorization header and then slice it. The first 7 characters, right? And that way, a slide would help me just cut it, and my token will be exactly what I need. So the first thing I need to do a try catch. Oops. I need to try something. I need to verify if my payload will be await, verify access token, and then I need to send my token and my secret. I need to send the token, and my secret will be my environmental variable. So it's in my context env dot jwt underscore secret. This being injected in runtime in my application percent, but it's in my backend, so it's not being exposed to my frontend. So I will try to do that. If that actually works, I will do, we can set our user, so we have access to our user data with that particular payload, right? And we go await next. That'll say that we're sending this to the next element. If something here fails, we need to catch that error. And we just need to return a simple for one. And that's it. So send error, we'll send the 401 if the header is not there or if something fails in this part, usually the verify access token. As simple as that. Verify access token, we return the verify, and that's pretty much a promise that will return or throw an error if something fails through that particular element. And that's it. So now we have our middleware there. We need to make the middleware usable somewhere. For that, we need to go back to our index and we need to tell, well, now I need you to actually use a middleware. The first thing that we need to do here is import out route, right? And for the out route, we just need to tell right here, I want to protect everything that is in the API. So I want to do API dot route. That means use, sorry. I want to for my here, the same way that we did this, it was a middleware that we just set it, the trace ID. So now we're saying that for the API per se, we use for everything. So we put the star one more time, authenticate. And for that, we need to actually import it. So let me just import it through here. And let's go to do something wrong. There you go. Yeah, it's a function, and we use it here. So we're just telling it that use my Authentication endpoint. But now I need to mount my authorization. The only things that I will to use here is my, and this just for simplicity, I will mount it before the authenticate. What I mean is my authorization endpoint for the API is not going through the middleware because we need to we don't need to have a protection for login and the other ones. We can somehow add that one just for specific elements, like if we want to do refresh, you need to be authenticated to be a refresh, or thing like that. You want, well, it doesn't make sense because the token already expired, right? So we those need to be protected, but we need to send information somehow. So that's what we're doing here. We just send in the authorization, authentication endpoint we mounted, but after that, with the authenticate middleware, we mount it in the rest of the API. That means our projects and our tasks are going to be protected, but authentication will not be. This will allow us now to actually make it work. Let me see if it's actually running. Yeah, it's a reload. Cool. That means if I go back here in my endpoints and I have my get alt projects, send it, this should fail. My trace ID I have right here, and missing by authorization header. If I want to get, I cannot do anything now. If I don't want to create a project, act as to create a task. Let's create a project. Should have something here. New project. Hello there. I'm your authorized. I cannot do it because I need to authenticate first. Also, you go back here. Let's go to the database. Refresh. User is still empty. Session is still empty. Let's handle that. So the first thing that occurs to me, I will create a new, and I forgot what it was. Mm, Here, new request. This one, it will be a post. Let me save it. Let me actually, what I want to do, let's do create task. Let's duplicate that one. Duplicate, send on the end, and let's change the name to register, right? And we need to call API authorization register. If we call this without anything body, we have a bad request. We have 400 response. That means that we need to send or correct data. So let's send that as a JSON and let's register, I don't know, for example, email. Let's do hello at there.com. If I send this, yeah, password is required. Okay, it's working. Let's do password. That's how is what I'm expecting, sending the email and the password. This is a simple hello. This should fail. Password must be at least S characters. Okay, cool. So if I did this, I have a user created hello at there.com. Even that I send it as a uppercase, it's being stored as a lowercase. If I get back and see my database one more time, my users, I refresh the users. I can see that my user there and my password is being hashed right here. Pretty cool, right? So this actually work. So now that I have that, I should be able now to log in. So let's to copy this over. Let's rename it to login. And to login, this should be here. Let me save it. And I will need to call login endpoint. And I need to send, I think the same body. Let's save this for now. If I try to log in here, I say, you know what? I'm going to format. Let me try to log in with fake username and password. Invalid email. It doesn't tell me which one is invalid. Or if it's both of them is actually is. So it's pretty cool. It's doing what it's supposed to. If I remove one, like, yeah, I cannot log in without password. Cool. But it's not telling me that the username is correct or not. So let me send the same one that we used for before I actually send it. Let me just get back here to show something. Our sessions are are empty so far. So now that I want to log in with the same user that I just registered before, and I have a server error that I should not have. Let's see what is the issue here. Um, Turning ID token hash expires at I'm sending parameter one. Yeah, my user ID. Yeah, created that. I knew that I have something with a with a typo somewhere. So the name of the object that I have is without snake case. So let me just look for that in my code. And that should be more likely in there. Where? Well, I can actually look it through here. It will tell me where it is. Where it fails. You say the middleware template. It's trying to do the session, compose. It's not telling me exactly where. Okay, so let's do a simple search. I can do in the source, right click, find in folder, created underscore add. So those actually fine. Those actually fine here. The snapshot, I don't need a snapshot either. Mm, Actually, I think I'm fine because I'm sending just created at this equals created at. That's fine. Snapshot is no use it. Interesting. I have somewhere in my file with a incorrect. So let's look for that. Let's look first here. Here. This one should be expires at. So more likely should be here. Here. I'm sending something wrong, probably. My schema is created at. So I'm not sending it. Session repository, create setup, and then it updated. It should be this created. Maybe. Yeah, it should be. Okay. Because for schema, and let me put the schema on the right. Where is my schema? Here. If you drag it to the right, you can see this. Oh, so, and let me minimize this. And I can see that my is user ID, token hash, expires at, and created at. See what's the issue? I was sending something to update it at, and that doesn't exist. It's expires at, and created at should be now ISO. And I think that should be it. This is user ID. The good thing, we are not using the AliExpress, but just to keep it consistency. And that should be it. Let me close this. Let me see if this is actually running. Cool. So I should be able. Let me try to register again, and this should fail because user with that email already exists. Cool. So let me log in. And now I have my access token and my refresh token. In my front end, I need to save this in my cookie or somewhere. And I need to save this in memory. So let me get this token here. Let me get the projects that is actually failing. If I go to authentication and I sense is a bearer token and I paste it, now I can see my projects. I don't have any project yet. Cool. Let's create one. Authentication, mirror, pasted, project created. If I get those projects now, I can see my project right there. Pretty cool, right? And the only way to do it is through the bearer token. If my token is manipulated somewhere, invalid expire, we just added an extra line. Put it through here. It's actually working. What I want to show you before continue with the rest, let me copy my token and I want to showcase something here. Let me see my browser. You go to jwt.io. We'll be able to see the code, the header, the claims, and verify if it's valid or not if we put the correct signature here. So let me just paste the one that we have. As you can see, we can read it. We can see the stop, we send the email, yet and expire. It's everything's there. That's pretty neat. And it says a valid WT, but it's invalid signature, right? The cool thing about this is we go back to our dev bars and copy the secret. And we paste the secret here. Signature verified. That's pretty cool. That's how it actually works. And that's what I'm saying, that this is not information that's being hidden. This is information that's being is easy to read. And the secret is just to verify the signature itself. But the rest of the data is all visible, right? So that's the point here. Pretty cool. Now that we have that, what else we can do? We can do refresh. Let me duplicate it. Let's get this descending. So let me pause the video for a minute and I will get back when my actual token expires so you can see what is happening there. Okay, my token should be already expired. So I have this. So something cool about this page that you can look at is when you hover over, you can see when it was created at 8:20 in my time, and it should expire at 8:35. So let's actually see that happened. So you can make another call, invalid expired token. Pretty cool. That's actually what we needed. So now we need to refresh it. So let's refresh this. To duplicate, let's change the name to refresh will be the refresh, and the body we need to send the I forget what we need to send the refresh token, refresh underscore token, I think, and we'll be sending the refresh token that our previous login gave us. We know that this actually expires in 7 days, right? If we go to the database and we see that here, oh, we didn't have it before. So when we log in, we actually see it there. And this is our token hash, right? And it says when expires is pretty much in 7 days. Here, expires at. So let's go here. Let's paste that refresh token and send as post. Invalid expire refresh token. Ooh, we send something here? No. We want to send it as refresh token, probably. There you go. Validation error. It should be refresh token. Because this actually should work. So there is an issue here with a refresh being called as expire. So let's try to fix that right now. So to troubleshoot this, let's see. Okay, let's call the refresh. Right here, no. Authentication, refresh. Let's do simple console.log token hash. Uh, let's try one more time. We know that this should work. That one is right here. E3 and finish with 55. So the hashing should be pretty much the same as the one that we have here. No, this actually start with C1. Interesting. Let's try to log in one more time. That should create a new session. Let's try to refresh this one. Still fails. What about the new one? Oh, more format. I need to do this. It's still the issue. So this one, it's really similar. Oh, interesting. It's actually sending the same token. 8. Hmm. Our token is hashing the same thing over and over and over. That means that more likely our hashing function is having an issue. Okay. So go back to the authorization endpoint. Let's go to hash token. So this is having a particular issue. Let's verify that. Let me get back to my authorization. So let me get also the payload refresh token. Let's do refresh token and the token hash. I need to, let's console those two. Yeah, it reloaded. Perfect. And here, if I send this, oh, refresh token is undefined. That's the problem. This is the problem. It's actually not reading it. So because it's not reading it, that's why it's always hashing the same thing over and over. So let's go to route authentication. Oh, here the payload should be underscore token, right? If we do that one more time, there you go. We have a new access token now executed. Pretty cool, right? But now with this new access token, I should be able to get my project. This should fail. But if I change to the new one, this should work. And that's it. So that's the way that we need to refresh it. Here, the payload we call as a refresh underscore token. That's the way that I need to call it. I knew that I would have some kind of problems here and there with the typos, but now it has been solved. So after having this, we should be able to do a logout. If we go back to our sessions, we have three of them. We created three at the end. The last one, C9, is actually this one. Cool. So it's the one that is working. And let me see my authentication endpoint. We need to remove this one from here. We don't need to console it anymore. Cool. And now that we have that, the only things that we need to do now to test is the logout. So to test the logout, we will test the access token with the latest refresh. It's working. So that was created with this refresh, right? It's this one over here. Start with AJ and finish with 2SW. AJ and 2SW, yes. So now let's duplicate this. Let's call this logout. Oops, I duplicate twice. Let's rename this as logout. And I need to call the logout. I need to send that refresh token. And it fails one more time. And I think it's really similar to the previous error. I need to get the refresh underscore token. Yes, here. So if I log out that, you still have an error. Let's see what is the error now. Database delete is not a function. So it looks like I have an issue with my repository file in my session. So let's go to sessions. Where sessions token hash equal the token hash. So wait. Yeah, it should be like that. So let's start this one more time. Error. Mhm. This is a drizzle issue. So let's do drizzle. And let's look for delete. Database delete user. Where something. Okay. So database delete. That's what we need to do. Database delete. Where. Okay. Returning. Deleted ID. Yeah, we can return something. It should work here. Returning ID, session ID. That's what we're sending through here. Like delete ID, user ID. So something is failing here. This actually looks fine, and it looks like have the same convention. That means the error is not here. So where we initialize this, we initialize this in the route. Go to the route. Oh, right here. We are sending the ground database. It's actually sending something else that should not be. So this is the problem. Get DB. It was not there. Okay. That should allow us. Let's verify. Just restart. Perfect. If I do logout, it's still an error. Hmm. I have another error now. Let's check our session here. This one. This will be like this. Sorry, guys. So let me save it one more time. Let's reload it. Let's go to see the database. We have 3 sessions, and the last one should be deleted after logout. The one last logout. Okay. 204. No content, but it's successful. That will allow us to have this one refresh. Just two. Perfect. That will also make. Let's make another login just to showcase this. So let's log in. Let's use this refresh token to this access token in get projects. We know that is valid. Okay. Let's get the refresh token and let's do logout. So even when the access token was still valid, this session should not exist anymore, I think. Let's try it. Oh, yeah. That one is still valid. Well, that pretty much will end at the end of the 15 minutes per se. But now this particular token can be used to generate more access token per se. Yeah, here is because we are handling a stateless function, and that stateless function is not allowing us. We don't have even the state of the access token. If we have rotation of access token, we can keep like a blacklisted part, but I'm trying to skip that section. So we have most of the elements already working. That means that we should be able to fix this. So let me just correct this. Let me just send the sessions, fix typos, and then the authenticate JavaScript. This one, the out route is fix typos. Added middleware. And the last one, the index will be added out to epi endpoint and out middleware. Let's push all those. That will allow us now to have our application. So the thing here is, now that we have all this, we need to publish to production. We know that everything is actually working. We should be able to do first npm run database migrate remote. That will create the database inside Cloudflare. We'll say yes, proceed. Cool. Everything is there. And executing 4 commands. Cool. Let's see. Oh, brother, but I didn't tell the name of the last one. Let's just make sure that everything is should be. Go migrations. We have the sessions, we have the users, and here we have both projects and tasks. Cool. So now we know that our remote database have the elements that are needed. The other elements that we need to put here is with the secret per se. So now we know that we added. We need to send that to Cloudflare and contain it with the project we currently have. So inside my project folder, we will send a secret to Cloudflare, and we do that with Wrangler. Secret, put JWT secret. A really big secret, and we send it. And that will create a secret there. You say there's nothing there, you want to create a project? Yeah, let's do it. Let's get crawl upload, and then we can do simple npm run deploy. Cool. Binding the database person. Yeah. Cool. Deployment should be ready in this particular folder. Okay. So they will allow us now that has been deployed. Let's test it out, right? So we should be able to get project instead of localhost. Let's change to here. Unauthorize, that doesn't exist. Let's register. Let's do this username. Okay. Let's log in and look at the change the URL. Cool. Let me get my access token. Put it here. I'm sending to my production endpoint now. It's empty. Nice. Let me create a project. That project will need project. Hello there. Mm. Oh, I need to send it to here. Create project to here. Cool. Yeah, it's been saved. All this is actually been saved in the cloud and it's been protected. Let me just create a task. Actually forgot how to create a task. Let me just put the endpoint. Let me get the bearer token. And let me send that. And I need to send a raw JSON file. I need to send title, I think. Yes, title. New task. And I think it's description, probably. New task description. Cool. If I get my project, I should be getting that. And project by ID. If I get my project number 1, that I have it here, this should work. Until I actually put, well, there you go. Authorization, bearer token. Let's use this one over here. How cool is that, right? Get tags bus project ID. I'm just testing pretty much everything. And this will allow us how it's not deleting. I don't know why. Mm. There you go. And we get the task. That's actually pretty cool. We can verify if my access token can be refreshed. It is. Can we do a logout? Yeah, it does. So that's it. That's pretty much everything there. Now we have a production application set up. And that's why wanted to wait till now. Now, what I will be doing after the video, of course, I will delete that username with that connection. So it's not actually being handled by to create new elements. But we have the register working. We have the login and never to deploy to the correct URL. So what I need now is 2 things. I need your GitHub URL with everything deployed, with everything committed, and this particular URL. Remember that before we deploy it, we did 2 things. We migrate to production, to remote. We set up the secret, and then we deploy. So I think this is a really long video now, but I hope that you really like it. If you have any question or doubt, don't hesitate to reach me. Happy coding, everybody.